Hello, everyone. So this is my Capstone number one. I'm Osric, and it's an exploratory data analysis for wholesale produce prices in Canada for 2024. The table of content. So first, we're going to do some introduction. I'm going to tell you about the data sources and basics of the metadata, really. We're going to do some data wrangling, look at the analysis, and going to draw some conclusions. The introduction. So, I just want to tell the motive behind why we're doing this. Prices for everything has risen lately, certainly in the last few years, and groceries and produce section are no different. So I want to look at the prices of various products, mostly fruits and vegetables here that we're going to look at. And in this presentation, we're going to explore how the price has changed for different types of fruits and vegetables. Um, is there discrepancies between the two markets, namely Toronto and Montreal? And which commodities really had highest average price and volatility. Now, when you look at the description of data, it's daily wholesale price report, and it's from open data set from Canada, and here's the source to it. It it's about the daily price range of different horticultural commodities, and the data are from selected wholesalers, and it's reflecting the wholesalers' asking price to retailers and includes details on the commodity size, variety, origin, and pack sizes. So the data, it's really 42 and a half megabytes in size, the data source that I talked about, and it consists of 197,585 rows and has 23 columns. And now those 23 columns, most of them are just repeated, since this is federal government data, and the official language is English and French. So a lot of them are repeated, which I'm gonna tackle in the data wrangling stage. And the rows date starts from 15th of January of 2024, and this data ends at 27th of January of 2025. So we have a good year of data, and the cities in this wholesaler data is only Toronto and Montreal. Unfortunately, I would have loved to see more cities, but namely Calgary, Edmonton, and Vancouver. But that's all that I had, these two cities. Um, Now, the commodity list of this data, there were a total of 111 different commodities. And as we see here in the screen, this is a Python list of all the commodities included. Consists of alfalfa sprouts, apples, apricots, artichokes, and it goes on and on for different kinds of fruits, vegetables, and such. So, um, now the data columns, it was not very intuitive. So the first thing I did was dropped all the columns that were in French and remapped it to something that is much more intuitive, and it was clean to this list over here. Next, I converted the date from the default to a pandas date time data type. And I also added a column for average price and price range. So that originally the column only had low and high price, so added them up and divide by 2 for average, and the difference between high and low is the range. Another thing that I did was converted the units, different types of units in the data, to kilograms. I used a conversion factor for pounds and grams and ounces, and just iterated through this dictionary, both keys and value, and applied that to our data frame, and change it to kilogram here. Now, for data analysis, I group the data frame by commodity and calculate the average price for each, and then showed the units of measure in the same data frame. So this is what I did to take the means, and I just rounded to two decimal place, and then added the unit, and then concatenate these two data frame so that the data frame average price has the units. And then from that data frame, I dropped those rows which didn't had any unit of measure, and then I tried to print it. And yeah, this is basically that data frame with a subset of that data frame. And only this subset only includes commodity, average price, and unit of measure. And to make it easier to fit on screen, I just printed the first one and the last four. And as we can see, it ranges. The nuts are quite high, but alfalfa sprouts are a bit cheaper. And then I made a histogram using Seaborn and plotted it for different commodities and sorted from highest to lowest here. Next, I didn't just want to look at the average price, but I wanted to do a more of a time series, see how the price changes over time. And for this one, I didn't want to go through all 111 commodities, at least not for this presentation. I did that in the Jupyter notebook, but for the presentation, I'm just showing the top 5, which is why we have this head 5, and to show the 5 most volatile. I took the data frame, sorted by the volatility, and if those commodities, if those volatile commodities are in that data frame, I just took that and then grouped by the commodity and then by date. And I only took the average price of that, and took the mean of that and unstacked that commodity, and then I plotted it to a figure size and added various parameters to the plot. So these are those 5 commodities: artichokes, ginger, lemon, lime, and this thing called rambutan. Now the rambutan has only a limited amount of data, but I still left it here because I took the 5 most volatile, not necessarily the 5 complete data, or the commodities that had data from January all the way to next January or 2025. And this was really because of volatility rather than range. And one interesting thing that I observed was lime and lemon here. They're almost inversely correlated. As lime is going down, lemon is rising, and and vice versa, right? So that is an interesting find. Now, I could have done that for 100, all 111 um, commodities, but it would just create lots of noise in this plot. I will be posting this notebook as well, so that would help anyone who wants to examine further and not just look at five most volatile, but any other commodities as well. Now the data wrangling part. Another thing I wanted to do was categorize this data into various different buckets. These commodities, there were 111 of them, and I just categorized into either citrus fruit, berries, tropical fruits, stone fruits, other fruits, um, vegetables such as leafy greens or root vegetables, cruciferous, squash and gourds, alliums, which is like garlic and onions and shallots, peppers, exotic vegetables, herbs and spices, sprouts and microgreens, nuts and exotic fruits. And then I applied those category to that data frame. And Now with that, our data frame also has a new column called product category. And finally, for this part of exercise, I wanted to group by the column called center, which is really just the cities that we talked about, Montreal and Toronto, and then grouped by the different product category for each city, and took the average price, and then took the mean and unstacked it, and then I plotted that. First I wanted to show those two data sets for different cities. As you can see here, Wholesale Montreal and Wholesale Toronto, and these are the top 5 product categories. Then for each of those categories, I wanted to see if there are any differences by cities. As you see here in this graph or chart, for certain types of commodities categories, the Montreal has the higher price than Toronto, but for others, Toronto had the higher price. Now, so we don't have a definitive answer whether Montreal is on overall cheaper or more expensive just based on this data alone. But I would have loved to see, as I mentioned earlier, other cities as well, whether certain cities are consistently cheaper than the others. And that brings to the end of our presentation. We saw that the prices have seen dramatic changes in the wholesale markets. There is some discrepancies between cities, but there is a varying trend, and it's not consistently one city being consistently cheaper than others. And we looked at different commodities that had higher prices than others, and that can be shown in the data frame as well. So this was my presentation. Thank you very much. I will be posting the notebook along this. Bye now.